All right, jumping into law of cosines. So when I look at these law of cosines formulas, quite frankly, I think that these are a giant hot mess and I really don't want to work with them at all. So as I was working through them, I have come up with kind of my own way of working with these problems, and we're really not going to pay so much attention to the three separate formulas, but we are going to pay attention to the fact that these letters there are the same. So these two that are squared together and added in the top, I'm going to multiply them together by 2 in the denominator. And that is consistent throughout each of the formulas. So remember that idea? We're going to come back to it. So we're going to jump in first to an example here. And we're just going to draw our picture. So we've got Amy playing field hockey. No idea how field hockey works. I personally think that the sticks in field hockey are really weird looking. Don't know what they're talking about. They just look strange. Okay, so we've got Amy. We're going to put Amy out here. And it says that the field hockey goal is 12 feet wide. Okay, and since Amy is super smart and she's always working on her math, she's going to immediately estimate that she is 45 feet from one of the goals, because I'm sure that's what all athletes do when they're out in the field, is they estimate their distances to each of these goals. Then she estimates that she is 37 feet from the other goal, and you'll notice that I've given these other locations names. All right, so here's Amy. She's made these good estimates because she's super smart and great with estimating. And the question is, what is her angle to make a shot on goal? So we need to solve for angle A. Now, when we look at these three forms of law of cosines, these are all perfectly set up to solve for an angle. Now, how do I know that I want to use one of those formulas? How do I know that I'm not using law of sines? Well, I know I'm not using law of sines because there's no link. Remember back when we talked about that link for law of sines, meaning that we knew an angle and we knew a side across from it. Well, we don't have that anywhere here because we have a side, side, side pattern. Okay, so we're going to use our new method. So we want to solve for angle A. I'm going to circle A so I can focus on it. And sitting there at your desk, I want you to take your peace fingers and raise them high above your head. Right now, raise them high above your head. Okay, good. Got your peace fingers. You're going to take your peace fingers and you're going to put them on the sides that are adjacent to that angle that we want to find. Okay, if we want to find angle A, we know that we're going to use cosine A. And our peace fingers tell us those numbers that need to be squared and added in the top and multiplied together by 2 in the bottom. So peace fingers on each side of A. So I'm going to write 45 squared plus 37 squared. And the bottom, I'm going to write 2, and parentheses are kind of nice here, 2 times 45 times 37. And now that you've got all that set up, you're really only missing one tiny little detail. So the last little thing we're going to do is we're going to look at that side that's across from where the angle we want, and we're going to subtract its square. Now, if you've got that all set up, you are ready to type this into your calculator. So we're going to type this in our calculator here. And we can type it in exactly as we see it. It's important to make those sounds. Okay, so I got a 45 squared plus a 37 squared minus a 12 squared. And that gives me my nice numerator. I like to do it in pieces, divided by, I'm going to use some parentheses, 2 times 45 times 37. And I get something kind of weird. Oops, sorry. I did that too fast. 2 times 45 times 37. Okay, so now I get this funny decimal here. Remember, we're solving for an angle, So since we're solving for an angle, we're simply going to use our inverse cosine of that answer, and we can get that Amy's shot on goal is approximately 13 degrees if I round that to the whole number. Okay? Now, of course, we are not always going to be solving for angles. We are also sometimes going to be solving for sides. So down below, we're going to take a look at what to do for that. And I'm going to give you two options. So here we go. First thing, got to draw a picture. So draw any triangle that makes your heart feel happy. I generally suggest not making isosceles or right triangles. Just going to put my numbers on here. We've done this before. This isn't anything new. Got my 40 degrees. I've got my 100. All right. So now, again, no link. If there's no link, meaning nowhere in this picture do I know the measure of an angle and the side across, the measure of an angle and the side, or the measure of an angle and the side. No link, gotta use our law of cosines, which means piece. Gotta use your piece fingers. Here we go. Find AB. So I'm going to find segment AB. It's across from C, so I'm going to put my C on there. Okay. Before I jump into this computation, I'm going to come over here and I'm going to take this problem. Okay. Notice that I've grabbed my formula that revolves around angle C. Okay. If I put my piece fingers on there, that would give me my A and my B and my 2AB. Okay. So what we want to do is we want to solve this equation so that we can get the C all by itself. First thing that we're going to do is we're going to picture this left side over 1. Think a nice cross multiplication. So I get this 2AB. If you want parentheses, you can. You don't have to. Cosine C. And then A squared plus B squared minus C squared. Lovely. Now, I need this C squared. I notice that it's negative, so I'm going to take the C squared and everything on the left, and I'm going to flip-flop them. So I'm going to get a nice C squared, and now I'm going to have an A squared plus a B squared minus this entire thing. I'm going to put that in one big parentheses, 2AB cosine C. Then, we're almost done. We need to take the square root of each side. So, C is equal to the square root of A squared plus B squared minus 2AB cosine C. So, you've got some choices. You could set this problem up just using piece fingers and go through this algebra each time. Or you can jump right into this formula. So if I want to find angle C, or side C I meant to say, I know I'm going to have a great big square root there. Now, where are the piece fingers in this problem? The piece fingers, remember, they're squared and added, and they're multiplied together by 2. So here's the angle C. Grab it, take your piece fingers, put it on each side of angle C. So that means that we are going to do 150 squared plus our 100 squared minus our 2 times our 100 times our 150 times our cosine now of that angle that we're looking at. And now this is ready to just type in our calculator. So if I was going to type this in, what I would do for sure is clear everything out. I'm going to do my 150 squared plus my 100 squared minus, and now I'm definitely going to type this parenthesis and no more parentheses after that, 2 times 100 times 150, oops, I want 100 there, not times 150 times cosine 40, and I can just press enter, or I can double close my parenthesis if I want. So I get this enormous number. Definitely that side in the triangle is not that. Why? Because I need that square root. So we can go ahead and write this middle step if we want, but we're not going to clear our calculator. 9518.67. Square root. There we go. Now, one last thing when you're all done with these. Take a moment to look at your triangle. Make sure that it makes sense that the sides of your measurements are their sides versus your angles. So if you know all three angles, which you would eventually know if you solved the whole triangle, make sure that the smallest is across from the smallest and the biggest is across from the biggest. Okay? All right, that's all that we have on that piece.